Hi there and welcome. Today I'll show a little video about the panel meter that I got on eBay. It's measuring both voltage and amperes, and I was going to swap out the meter in my power supplies that I got, but I think the voltmeter in my power supply is working pretty good already. So I'll just use the panel meters here for something else. Now if we take a look at it, it's about, let's say it's about 5 by 2.5, maybe 2 by 1 inch, something like that. And it comes in a plastic bezel which has some snap-ins here. So actually you just cut a square in your front panel and it snaps in automatically. That's really nice. It comes with 2 cables. One is a quite thick one, which is for the amp input, and the other one is a volt and the power supply input. The red and black, of course, on the volt cable is the power supply, and it goes up to 30 volts. And the yellow one is the input itself. If we take a look at the PCB, there's nothing much there. There's basically some LED displays on the back of the PCB, and on the front there's a little op amp, and there's a current shunt down here, a couple of trimmers, one for volts and one for current, and then there's a microcontroller from ST. And since this one works up to 30 volts, there's also a regulator down in the corner here. So yeah, it's quite a standard design for a volt current meter. But what is quite amazing is the price. I paid only €3. The quality looks nice. The plastic bezel is nice. It snaps into a square hole in your enclosure. It has some ridges here on these spring tabs, and it will fit basically any size enclosure with a wall thickness of about 2 millimeters or thicker. So yeah, I like it. It's not bad. It even has printed volts and amps on the front plastic. So yeah, a brilliant little meter, and let's switch it on and see how it works. And there we have it, and there's my first problem, because I specifically ordered one where both the voltage and the amp LEDs were red in color. I really don't like the blue one. It looks like something from a pimped out car, and that's really not my style. But anyway, if we just look at the functionality, it has 2 wires in, which is the red and the black one, which is for the power supply. And if you have a power supply that doesn't go down to below 5 volts, you can actually connect the input directly to the power supply. So that's a nice little feature. But otherwise, if you want to measure voltages all the way down to 0 volts, you need to have a separate power supply of something about 5 to 18 volts or 5 to 30 volts or something like that. But just for our testing here, I will connect 2 power supplies so we can see the behavior all the way down to 0 volts. So just give me a few seconds and I will hook it up together with my Fluke benchtop multimeter, and we can compare the reading of these two. So yeah, just 1 second and I'll be back. Okay, so I'm back now, and I have connected a 5 volt power supply to the supply for my voltmeter, and another power supply for the input voltage. My power supply is now sitting at 0 volts in. It doesn't go down to exactly 0, it goes down to 0.08 volts. But that's okay, the little meter is not measuring 4-digit accuracy, so that's fine. And let's just turn up the voltage. And let's just get it right. I have 1 volt on my Fluke, 1.1 volts on my Fluke, and 1.1 volt on my little meter there, and 1.5 and 1.5. Okay, so now I have my Fluke at 5.008, and my little meter from eBay, my €3 meter, is measuring 5 volts, 5.00. So that matches really nicely. And if I turn down my voltage slowly, we can try and get an idea of where exactly the little meter changes from 4.9 to 5. And then now my Fluke is measuring 4.97 and the top meter is measuring 4.9. So it is rounding down by a little bit, but once we reach 5 volt on the Fluke, it changes to 5 volt on the little meter. So it is really accurate actually, and the 0.1 volt accuracy seems reasonable. Let me just take it up a little bit further. I think the meter can handle 30 volts on its input, but my power supply can only manage 18 or 19.1, 19.2 volts. So yeah, it's definitely enough for using in a power supply, for example. The accuracy on voltage is pretty good. And see, in this case here, it's 0.2 volts maybe out of 20. So that's about 1%, and that's not bad for a meter that costs only 3 euros. So let me just reconfigure and we can measure the current. Okay, so I got it configured to measuring ampere, and I'm measuring current through a 100 ohm resistor, and I think it's a 5 watt resistor, so I have to be a little bit careful about how much current I send through this, but 200 milliamps should be no problem. So let's just turn up the current slowly and maybe go to something like 20 milliamps first. You saw the meter here, it switches from 0 to 20 milliamps. There's no 10 milliamps here. And now I'm at 20 and the blue one is at 20. So assuming that the meter from eBay is incremented at 20 milliamps at a time, it flips over, it rounds up at 10 milliamps to 20, which is nice and correct. So anyway, let's just continue up. Do you see that? It went to 30 milliamps, so it can increment at 10 milliamps. So there's something wrong at around 0. Yeah, I don't know whether this meter now is useful for electronics, because 30 milliamps is actually quite a lot when you're doing some microprocessor stuff. So I'll have a look at it later and see whether we can go lower. But anyway, a resolution of 10 milliamps is not too bad. Let's just continue up. 40, 50, 60. See, it went to 60 milliamp at around around 52 milliamps on the fluke. It changes to 60 milliamps on the little blue one there. So the linearity is not that great. And I'll continue out here. Now I'm at 100 milliamps and that is okay. Let me just feel the resistor here. It's not hot yet, so let's just continue up. Let's go to 200 milliamps, something like that. And I guess that's the most we can measure here on this power supply, because it's a 19 volts maximum output on 100 ohm resistor, so we should stop at around 180, 190 milliamps. And that's actually what we do here. The amp range is a little bit non-linear, but it's fairly accurate, and the volt range is spot on really. So yeah, it's good enough for car use or stuff like that. And I'll probably use it on my benchtop meter here as well, because 10 milliamps resolution is okay, I guess, for electronics work. It's not perfect, of course, and it would have been nice with a 1 milliamp resolution, but that's not what I ordered really, so that's my own fault. But yeah, so yeah, you can't really fault it, especially not for 3 euros. But whether it's useful for electronics work, I'm not too sure. But yeah, you could, I guess, modify the meter by changing the shunt and getting a higher resolution meter. In that case, of course, you also have to move the decimal point, but it shouldn't be too much of a problem. So just a quick little follow-up. I got the PCB out of the plastic enclosure, and it took a little bit of effort. The plastic wall is actually quite thick, which is a good thing. And as I said earlier, the PCB basically is single-sided. There's a ST microcontroller, a voltage regulator, and a couple of op-amps, and that's it really. And on the other side there's the display itself. So I was thinking of changing this meter to have a full-scale deflection of 100 milliamps instead of 1 amp. So I'm just going to measure the shunt here, and basically all you have to do is increase that by a factor of 10, and you will have a 100 milliamp meter instead of a 1 amp meter. Of course you have to handle the decimal point, and that's a little bit more tricky than I initially thought, because all the segments on the display are multiplexed. So you can't just cut one wire on the display. But anyway, you can just cover up the decimal point with some masking tape or a black dot of paint, because you won't be able to see it through the glass here anyway. So I'm afraid this is going to be a little bit tricky, because I have to show the output from my LCR meter as well as when I'm probing the shunt on this PCB. This shunt is really difficult to measure. But we're having it here 0.1 ohm, 100 milliohm. So if you change the shunt to 1 ohm, you will have a 100 milliohm range on your meter here. So I'll be doing that later. But anyway, that's it. Thank you for watching, and see you again later.